In this video, we'll learn how NAT instances can be used to provide internet access to instances in a private subnet with private IP addresses. Now, before we get into NAT instances, I just want to say this is really the old way of doing network address translation within AWS. So there's something newer called the NAT Gateway that we'll learn about in the next lesson. So let's lay our groundwork first. Let's talk about our VPC as we have seen it configured in our demos thus far. And if you're following along at home, this is something like what your VPC looks like right now. You've created a VPC. The CIDR range is 10.1.0.0/16, and you've created a public subnet, which is shown on the left, 10.1.101.0, and a private subnet, shown on the right, 10.1.1.0. So now that I've created my VPC and subnets, and I've also attached an internet gateway to my VPC so that my instances can have internet access, I've also got a router for each of those subnets. And each of these subnets has a unique route table. So right now, I've created a route table for my public subnet that has that local route for my VPC. So the first route entry is my local route, just directing traffic within the VPC. The second route is my default route, specifying that all traffic to any unknown destination should be sent to the internet gateway. And so I've established internet access for my public subnet at this point. However, instances in the private subnet, they don't have a route to the internet gateway, and therefore they do not have internet access. So we're going to learn how to use a NAT instance to give those private instances access to the internet. And so right now, our starting point is the main route table for the VPC. I've created a subnet. It's got the main route table. The main route table has that local route for the VPC. So it's got that local route built in there automatically for traffic within the VPC. However, it does not have a route showing it how to get to the internet. So at the moment, there is no default route, and I haven't created a default route with a specified target. So any traffic bound for anything outside this VPC is basically just falling into a black hole. So now let's say I want to give those private subnet instances internet access. One of the ways that I can do that is I can create a NAT instance. And a NAT instance is an EC2 instance based on a standardized AMI that's configured to perform network address translation. So once I create a NAT instance, and the NAT instance is in my public subnet, it's got a public IP address, I create that NAT instance, I can now modify the routing table of my private subnet. So again, at the moment, the default gateway of the private subnet, there is none. Right? We're using that main route table. There is no default gateway configured yet, but I can modify that routing table to point the default gateway to a NAT instance. That's my default route. So now any traffic for any unknown network will be forwarded to this NAT instance, to this EC2 instance. And so now let's add an EC2 instance to the private subnet. Here's my EC2 instance with a private IP address, 10.1.1.23. And let's say that this EC2 instance generates some traffic that is bound for the internet. Well, that traffic is going to flow to the default gateway of the instance. And the default gateway of the instance is 10.1.1.1. It's my router for that subnet. So when the traffic hits the router for the subnet, the route table is going to be analyzed, and the traffic is destined for something on the internet. Therefore, it's going to go to the default route of 0.0.0.0/0, my NAT instance. So the router forwards that traffic to the NAT instance. and the NAT instance receives this traffic. Now, when the NAT instance gets this traffic, the source IP address is going to be the IP address of this EC2 instance, 10.1.1.23. This is a private IP address. This address doesn't make any sense on the internet. The internet is going to have no idea how to get to 10.1.1.23. But remember, my NAT instance has a public IP address. So that's the purpose of the NAT instance. It's going to perform what we call a source NAT translation. It is going to pull out this IP address and change the source IP to this IP address. So when that traffic actually makes it to the internet, it'll have a usable public IP address. So now my traffic is flown from the source EC2 instance. It's hit the NAT instance. The NAT instance has modified the source IP. And when the NAT instance modifies that source IP, it sends that traffic out. How does it know where to send it? It uses the route table for its public subnet. This is some traffic that's destined for a specific destination IP. That destination IP is on the internet. So therefore, looking at the route table for this public subnet, any traffic that's bound for the internet is going to hit this default route and it's going to be forwarded to the internet gateway. And so out it goes to the internet with the translated source IP. So now when that traffic does hit the internet, it's going to have an internet routable IP address. And that's the way that we've done network address translation in the past. So this is the traditional way to handle NAT within a VPC. Now, I say that it's the traditional way because there is now a better way to do this. So let's think about some of the inherent limitations of this. In this really simple scenario here, it's a very straightforward, very simple scenario. As a matter of fact, in my VPC, my public and private subnets are actually configured in the same availability zone. So I've got a public and a private subnet that are configured in the same availability zone. If that AZ fails, it's going to take down everything that we see here. So an availability zone level failure would just knock everything out. But in most environments, that's not really the way that we do things. Typically, what we would see in a more typical production environment is there might be one subnet in a private AZ. There's probably going to be other subnets in other availability zones here as well. And they could potentially be using this NAT instance for internet traffic as well. So let's just call this one availability zone 1, availability zone 2, and availability zone 3 as shown here on the screen. Now I've got instances in 3 different availability zones that are all using this NAT instance for internet access. So if this availability zone fails, there are going to be instances that all of a sudden lose internet access. Those instances are still up and running, but their internet access is down because I'm running a NAT instance on an EC2 instance. So what I end up needing to do in this scenario is create multiple NAT instances, spread them across multiple availability zones, and manually script the failover of those NAT instances. So that's obviously a lot of work, right? And something that manually is going to take quite a bit of effort. If I can avoid that effort, if I can utilize a managed solution instead, that's going to make the deployment of network address translation in my VPC much easier. The other thing that we have to consider with a NAT instance is I'm deploying network address translation on an EC2 instance with a defined amount of CPU and memory. So what happens if the amount of traffic that this NAT instance is taking in starts to rapidly grow? The NAT instance may not be able to handle that sort of additional workload. So based on that, the NAT instance isn't going to scale automatically for me. I'm going to have to manually scale it. And if there's a substantial increase in traffic, I may need to add more CPU and memory, which means I'm going to have to change the instance type, which means I'm going to have an outage as I manually make that change. So there's a lot of manual work involved in these NAT instances. And that's really what you want to bear in mind when it comes to NAT instances is they are created on EC2 and there's a lot of manual work involved.